Okay, we're going to solve a few more absolute value equations. This particular video on absolute value equations is some of the more challenging absolute value equations to solve. So we're going to do 3 problems on this. And remember, we're going to follow the 5 steps that we followed in the previous video. The first step to solving an absolute value equation is we must isolate the absolute value part of the absolute value on one side of the equation. So if you look at this example on our left side, we see 1/2 is being multiplied by absolute value of 3c plus 5. So we need to cancel that multiplication, and we can do that by dividing. So we're going to divide by 1/2. We're going to do that to both sides. That will cancel that fraction, so we isolate the left-hand side of the equation to absolute value of 3c plus 5 equals, and we're going to actually divide each part by 1/2. So 6c divided by 1/2, well, that's actually the same thing as multiplication by 2. That's 12c. And 4 divided by 1/2, same thing as multiplication by 2. That's 8. So we have now isolated the absolute value bars. We can set up 2 problems. So when I set up my 2 problems, the first one just essentially drops the absolute value bars and you keep all the signs the same. In the second equation, we're going to keep 3c plus 5 equal to the negative of the other side. So we will go ahead and solve each of these equations. Subtracting 3c from both sides is going to give me 5 on the left-hand side, and 12c minus 3c is 9c plus the 8. Continuing to solve, subtracting 8 from each side, we're going to get 9c left on the right, and 5 minus 8, that is negative 3. To finish, dividing by 9, and we've got a lovely fraction to reduce here. Negative 1/3. That is one possible solution. We know that all of our solutions are just possible solutions at this point. We have to check them to know for sure. So let's solve the other equation. Here I'm going to add 12c to both sides. So that's 15c plus 5 is equal to negative 8. Subtracting 5 from both sides of the equation, that gives me 15c equals negative 13. To finish, we'll divide both sides by 15. And that gives me c equals negative 13/15. And again, we're only going to say that this is possibly a solution at this point. We have to check to be sure it actually solves the equation. So we're going to check our 2 possible solutions by substituting them into the original problem. There we go. There's the original problem. Substituting into the original problem and see if they make this equation true. So here I've substituted 1/3 into both sides of this equation, negative 1/3 into both sides of the equation. Following order of operations, I'll start working inside this absolute value. 3 times negative 1/3. My 3's will cancel. That leaves me with absolute value of negative 1 plus 5. 1/2 on the outside here. I'll just continue working on this left side. And negative 1 plus 5 is 4. So I know I'm going to be finding half of the absolute value of 4, which is 4. And half of 4 is 2. So we want to see if the other side equals 2. So on the other side, 3 goes into 6 2 times. That gives me negative 2 plus 4, which is 2. That's true. So negative 1/3 is a true solution. Okay, on the left side, following the order of operations, if we simplify what is inside the absolute value bars, we get 2.4. And on the right side, we're going to get the decimal negative 1.2. Finishing the left side, 1/2 times 2.4. 1/2 times 2.4 is 1.2. And we're saying, does that equal negative 1.2? No, it does not. Therefore, negative 13/15 is not a true solution to this equation. We would call that an extraneous solution. So just say no to negative 13/15. It is not a true solution to the equation. So our true solution in set builder notation would be C such that C is equal to negative 1/3. Okay, here's our second tricky example, and I noticed first thing that it also does not have the absolute value bars isolated. So in order to start this problem, we need to divide both sides by 5. Be careful here, because I've had lots of students who want to use the distributive property, but the distributive property does not exist when we're dealing with absolute values. So in order to undo the multiplication by 5, we have to divide by 5. So that cancels the 5. We're left with absolute value of 6 minus 5x equal to 15 divided by 5 makes 3. So we get 3x minus 7. Once we isolate the absolute value, our second step is to create two problems. So our first problem just drops the bars. 6 minus 5x equals 3x minus 7. Or our second equation would be 6x minus, 6 minus 5x equals negative 3x plus 7. So in the second equation, we change the signs of all the terms that come after the equal sign. So now that we have our two equations set up, we're going to solve each of these. The first one, I'm going to get rid of this negative 5x by adding 5x to both sides. And that's going to be 6 equal to 8x minus 7. Then adding 7 to both sides so that we get all of our constants on the left and our variable x on the right. Then dividing by 8. See this? These problems are really just not very pretty. But that's real life. 13/8 is a possible solution. Let's look at our other equation that we wrote. Let's see, I'm going to get rid of the negative 5x by adding 5x again to both sides. That's going to give me 6 equal to 2x plus 7. Then subtracting 7 so that I get my constants on the left and my variables on the right. So negative 1, let's move this. It's going to be equal to 2x. Then dividing by 2, we get another possible solution of negative 1/2. So we have two possible solutions, 13/8 and negative 1/2. We must check to see if they actually work. So what I've done here is check the first solution of 13/8. I have substituted in place of x everywhere in this equation, the original equation, 13/8. The left side I evaluated with my calculator to be 10.625 and the right side to be negative 10.625. Since that is not true, then we would say that 13/8 is an extraneous solution. It does not solve our equation. So I've checked the second solution and I substituted -1/2 in for x on both sides. I evaluated with my calculator. The left side equals 42.5 and the right side equals -42.5. So again, that is not true. So we're also going to reject -1/2 as a solution. So we would say that there is no solution to this absolute value equation. Another way to write that is this symbol that means the empty set, which also means there is no solution. In this third problem, we are going to have to isolate the absolute value bars, but if you'll notice on the right side, we have a 4 in front of a quantity x minus 2. Now, x minus 2 is not in an absolute value quantity, so here we actually are going to use the distributive property to remove those parentheses to start. So that's going to be 4x minus 8. And I'm rewriting the left side, 2/3 times absolute value of 3x minus 6. Okay, so we still need to isolate our absolute value bars. So we're going to do that by dividing by the fraction 2/3 on both sides. So that's going to eliminate our fraction. And so I have absolute value of 3x minus 6 is equal to, here I'm going to be dividing 4 by 2/3, which is really 4 times the reciprocal 3/2. 2 goes into 4, 2 times, so it's 2 times 3, 6x, minus, we're going to do 8 divided by 2/3, which is going to be times the reciprocal 3/2. 2 goes into 8 4 times, so that's going to be 12. 4 times 3. Okay, so now that we have isolated the absolute value bars, we can set up two problems. So to do that, I'm going to drop the bars for the first one. 3x minus 6 equals 6x minus 12. Or in our second problem, we're going to keep 3x minus 6 and change the signs of everything after that equal sign. Negative 6x plus 12. So let's work on solving this equation on the left side. I'm going to get rid of the 3x, so subtracting it. So negative 6 equals 3x minus 12. And then we're going to add 12 to both sides. So that's going to give me 3x equals positive 6. And lastly, divide by 3. So x is 2. Remember, that's just a possible solution. It may or may not work. So looking at the other equation we've set up, let's add the 6x to both sides. And we could start this different ways, but this is just the way I'm choosing because it keeps me from getting a negative. So 9x minus 6 equals 12. Then to cancel the minus 6, I'm going to add 6. You guys are probably really good at this by now. And that's going to be 18 dividing by 9. And let me get some more space here. X is going to equal 2. Remember, that's just a possible solution. That's interesting. I did both of these problems, and I got the same possible answer. So, we need to find out if 2 really solves this. So the next thing we need to do is check our solutions to see if 2 is indeed a true solution for this absolute value equation. So we're going to always go back to the very original problem to do that checking. So substituting 2 in place of the x in the original problem will simplify. So inside the absolute value, 3 times 2 is going to give us 6. And then 6 minus 6 will be 0. So the absolute value of 0 is 0. Multiplied by 2/3. And on the right side, 2 minus 2 in the parentheses is 0. So we're going to multiply 2/3 times 0 and get 0, and 4 times 0 and get 0. That is a true statement, so our solution of 2 is true. So our solution, written in set builder notation, would be x such that x is equal to 2. On a number line, we would just show 1 point plotted at positive 2 to show that our solution is equal to the number 2. So I hope that these 3 examples have helped you to better understand how to solve an absolute value equation in some tricky types of problems. Good luck. See you in class.